Question 4 says, which of the following transitions in a hydrogen atom represent emission of the longest wavelength photon? So in order to think about this, we need to think about this type of diagram right here, where we essentially have n equals 1, n equals 2, n equals 3, n equals 4, all the way up to n equals infinity. And what's happening here is if an electron falls from a higher energy level, say n equals 2, down to n equals 1, it will emit a photon. However, if an electron goes from n equals 1 up to n equals 2, one way that can happen is if it absorbs a photon. So we have to think about absorption and emission, and then we have to think about the amount of energy. So first, we need to see that if it's falling down, that's an emission. The second thing we need to see is how much energy there is. And what you're going to see is these gaps get progressively closer and closer and closer together. So if something falls from 2 to 1, that's going to be more energy than if it falls from 3 to 2. And if something falls from 3 to 1, that's going to be more energy than if it's 2 to 1. Now, we need to think about this in terms of wavelength. So we have quite a lot going on here. So I'm going to kind of break this problem up into parts. And the first thing I'm going to do is find all the ones that are emissions. So we have a higher energy level to a lower energy level. So if you look here, 4 to 2 is an emission. It's at a higher energy level and it falls to a lower one. So this is a possible answer. 3 to 1 is an emission. Okay. 5 to 4 is an emission. 3 to 4 is not an emission. This is an absorption because it started at a lower energy level and went to a higher energy level. And 1 to 2, same thing. It started at a lower energy level and went to a higher energy level. This is an absorption, and it can't possibly be the answer. Now the next thing I want to look at is this longest wavelength photon. Long wavelength means low energy. So we want the lowest energy absorption. So what I'm going to do is I'm going to try to redraw what we had before so I can write on it. So this is n equals 1. This is n equals 2. This is n equals 3. This is n equals 4. And then n equals 5, because that's what we have on our list. Okay? So we need an emission with low energy. So if we look at 4 to 2, we have n equals 4. Let's say we have an electron here, and it falls down to n equals 2. Well, we have energy on this axis, and you can think about it as this is this much energy. All right, we don't have our axis labeled. In a future question, we'll actually find out the amount of energy for something like this, but here it's about this relative amount of energy. Let's look at the next one, 3 to 1. So if we look from 3 to 1, we have the electron falling this far and emitting a photon with this much energy, which is certainly more energy than from 4 to 2. Now let's look at the last one, 5 to 4. This one's going to be hard to draw. So it's falling just this little tiny gap right here. So this is clearly the lowest energy because it's the smallest gap here. It's fallen the least amount of distance. So if this is low energy, it's going to have the longest wavelength. We need to remember the relationship between energy and wavelength. So if energy is high, frequency is high. If wavelength is long, energy is low. Said another way, low energy is long wavelength. So the answer here is choice letter C.